Hello, guys. Good morning. Good morning to all of you. We are here with another session. Today we'll be starting Fourier series, and this is the first part of the Fourier series. You know, hello, guys. Good morning. This is one of the most important topics for mathematical methods. So let's start. And guys, if you have not joined our discourse, you can join it. All the links are given in the description. So without any further ado, let's start. Is everything all right? Okay, so let's start with the doubt which you have. Harry, you have given some doubts. Okay, let's take up that first. So as I told you, this special formula, this formula is very special. Minus infinity to plus infinity x to the power n, then e to the power minus ax square dx. This was the formula. This is equals to 1 into 3 into 5 and so on up to n minus 1 root over pi by 2 to the power n, then a to the power n plus 1. This is valid when n is greater or equals to 2 and even, and for the odd values of n it is 0. Okay, then we had an integration like this: minus infinity to plus infinity ax square minus 2 whole square e to the power minus x square dx, and we got a result like a square multiplied by 3 by 4 plus 4 minus 2a. So this part you did not understand. Okay, so it's very simple, na? If you just take this part, minus infinity to plus infinity, what will be the middle factor? What will be the expanded form? A minus b whole square form. So this is a square x to the power 4 minus 2 into ax square minus 2. So 4 ax square plus 4 e to the power minus x square dx. So what you can write: a square minus infinity plus infinity x to the power 4 e to the power minus x square dx. This is the first term, minus 4a minus infinity plus infinity x square e to the power minus x square dx, and 4 times minus infinity plus infinity e to the power minus x square dx. So it is very easy to remember. It is very easy to now find out. You know the formula, right? If this for this n equals to 4 here, for this n equals to 2 here, if nothing is there, you can consider okay, for this there is a separate formula: e to the power minus ax square formula root over pi by a. So here e to the power minus ax square, if it were there, then the formula will be root over pi by a, but only e to the power minus x square is there. So 1 into x square you can consider, so pi by root over pi by 1, so root pi. So in this way it has come. From this first integration you are getting this term, from the second integration you are getting this term, and from the third integration you are getting this term, and root over pi is multiplied for that. Now did you understand this? Tell me. Harry, this was your doubt. Is it clear now? We'll start Fourier series today. Okay, so let's start with periodic function. What do you understand by periodic function? This is very important definition you need to know before you start Fourier series. Periodic function is that function which repeats itself after some interval. A function which repeats itself after equal interval. So if f of x is a periodic function of x with period t, a function which repeats itself after equal interval, the interval is known as period. So if a function f of x is a periodic function of x with period t, then we can write that f of x has same value after an interval of t, after next t interval, so x plus 2t, and so on. So there are a lot of examples of periodic function. The most popular examples are like sin x, cos x, sec x. So these are the functions which are periodic in nature and they repeat itself after an interval of, what is the period of these functions? Do you know? What is the period of this function sin x, cos x? After how much interval they repeats itself? Tell me quickly, what is the period of sin x, cos x? This is one type. Then what is the period of tan x or cot x? So you know sinusoidal functions like this, they repeat after some interval. So what is this interval? Zero, pi by 2, pi, 3 pi by 2, 2 pi. So this interval is 2 pi. So t is equals to 2 pi for sin x. For cos x also you will see, you will get t is equals to 2 pi. For tan x, cot x, the interval is pi. Now let's say if you have sin 5x instead of x, if you have sin 5x, then what will be its period? What will be its period? For sin x, the period is 2 pi. For sin 5x, the period will be, if you consider this sin 5x, we can write it sin 5x plus 2 pi. So this is equals to sin 5x plus 2 pi by 5, right? So its period t will become, instead of 2 pi, it will now become 2 pi by 5. Understood? Whatever things will be multiplied with x in calculating the period, that factor will be divided by the original period. So you have understood the definition of periodic function. Let us now talk about Fourier series expansion. So what do you require Fourier series expansion? Any non-sinusoidal functions. Non-sinusoidal functions means it can be exponential, it can be some polynomial or some other functions. So functions which are not in the form of sine or cos, those are non-sinusoidal functions. So any non-sinusoidal functions can be written as the sum of sinusoidal functions. Can you imagine? Any non-sinusoidal function, you can represent them in terms of sinusoidal functions. This is what we do in Fourier series expansion. Okay. Okay, let me just do one thing. Let's delete this one. I am running out of space. Okay. So let's give the heading Fourier series expansion. It's a very easy topic. I will tell you, a little basic thing is there. If you understand that, then you will be able to solve any questions from this. A non-sinusoidal periodic function can be expressed as the sum of a set of sinusoidal oscillating functions or periodic functions. That is mainly sine and cosine functions. Or you can also express it as complex exponential. This case we will also discuss. Complex exponentials. This series is known as Fourier series. Look, Fourier is a name of a scientist, so you will always write this F in capital. Fourier series expansion of the non-sinusoidal periodic functions. How it is expressed? Any non-sinusoidal function f of x is written in this way. So there is a term, constant term a0 by 2. This term is not frequency dependent, but a0 we have already taken, so we will start with 1 to infinity n cos n pi x by L plus n is equals to 0 we cannot take because that will make the sine term 0. So we will start with 1 to infinity bn sine n pi x by L. You see, for this we have taken n equals to 1 to infinity because we have written it separately. Cos 0 is 1, so for cos all n values are there, you can say, but for sine it starts with n equals to 1. There is no such term like b0 because for n equals to 0 this sine term will be 0. These coefficients a0, a1, an, bn, these are constants and they are known as Fourier coefficient. Now if you closely look at the first term, which is our a0, this is a constant or also called a DC term, constant term or a DC term. Now for this an, you see a1, if you take n equals to 1, you have cos pi x by L. If you take n equals to 2, you get a2 cos 2 pi x by L. Okay, then and so on, you can get various terms. So okay, let's do one thing. This is the first term from this, and if I consider the first term from the second one, what we have? We have b1 sine pi x by L. So these first terms are known as the fundamental frequency term. Fundamental frequency term. So fundamental frequency term, what do we have in fundamental frequency term? They are having lowest frequency terms, having lowest frequency, and as you go on by increasing the value of n, you can get a2 cos 2 pi x by L or a3 cos 3 pi x by L and so on. On the other hand, you can get b2 sine 2 pi x by L or b3 sine 3 pi x by L and so on. These are called overtones. You must have read in waves and oscillation chapter in your BSc. They are overtones. It was there in class 12 also, this kind of term. So these terms having frequencies integral multiple of the fundamental frequency, integral Integral multiple means it is multiplied by some integer like 2, 3, 4, 5 and so on. Terms having frequencies integral multiple of fundamental frequency term. Clear? And that is the relevance of this thing, sinusoidal oscillating functions. These are all oscillating functions. Let me know once you are done. Let me ask you a question. You have Taylor series expansion, and now I am explaining Fourier series expansion. What is the need of the Fourier series expansion? As we have already Taylor series expansion. What is the basic difference between Fourier series expansion and Taylor series expansion? Anyone knows? What is the fundamental difference between Fourier series expansion and Taylor series expansion? Which one is superior according to you? Which one is more useful? Any idea? You see, for this Fourier series expansion, we have talked about non-sinusoidal, so it becomes any function. So this is a fundamental difference when a function and its derivatives are continuous. This criteria must be satisfied when you have a function and its derivatives are continuous, then only you can expand it by Taylor series. But for both continuous as well as discontinuous function, you can expand it by Fourier series. So this is the basic difference. So which one is superior? Obviously Fourier series expansion is superior because it can handle both continuous and discontinuous functions. Both series expansion possible by Fourier for continuous and discontinuous. But for Taylor series, it must be a continuous, not only the function but its derivatives also. So this is the basic difference between Taylor series and Fourier series. And this one I have already explained. The coefficient A naught is used to hold up the DC value of the time domain waveform. This can be viewed as the amplitude of a cosine wave with zero frequency, isn't it? A0 cos n pi x by L. So that is why it is A0. Cosine wave with zero frequency or constant value. B0, there is no term like B0 because sine wave of zero frequency has a constant value of 0. B0 sine 0 pi x by L equals to 0. Just write it quickly and let me know once you are done. Now to expand any function in Fourier series, it must satisfy certain conditions. Those conditions are known as Dirichlet conditions. So in the next slide, we will be giving you the Dirichlet conditions. Look, this is just for your conceptual development. In actual problem, you don't require this Dirichlet conditions and all, but you should know in and out of any topic. Whenever you are studying a topic, you should know the fundamental things also. That will help you in long run. Quick guys, let me know when it is done. Now just write down quickly this Dirichlet condition. Okay, before I start Dirichlet's condition, can you tell me the difference between these two? Let's say if you have AB and AB, do you know what is the difference between these two things, two interval? Anyone knows the difference between these two things? AB written in the first bracket, AB written in the third bracket. Do you know what is the difference between these two? Look, Dirichlet's condition, suppose a function f of x is defined in the interval a b. So whenever you see the interval in the first bracket, it means open interval. It means the values between a and b will be taken except a and b. Except a and b with a and okay, I understood Murli. So if you, let's say 2, 10, so for this case all the values between 2 and 10 will be considered except the value 2 and value 10. So in between them are allowed. This is the meaning of open interval, and there is a closed interval AB. This is closed interval. For this, if you, let's say closed interval of 2, 10, so all the values between 2 and 10 are allowed, along with the values allowed at 2 and 10. Okay, these are the two meaning. Suppose f of x is defined in the interval open interval AB, and if it is single valued means, you know, if you have a function f of x, for each value of x, if you get only one value, then that is single valued. On the other hand, if you have a function which has multiple values for a single value of x, let's say a function is of the form like this. So if you consider any point, let's say this point, so at this particular x value, as you can see, there are multiple fx values. So this is multiple function, multi-valued function. It is bounded in the interval AB. It has at most a finite number of maxima and minima in the interval AB. There can be finite maxima or minima also in the interval AB. It has only a finite number of discontinuity in the interval, and it is periodic. F of x plus t equals to f of x, where t is equals to b minus a for all values of x outside AB then you can expand it in this way, fx equals to this. Just quickly write down, these are the standard Dirichlet's condition. Yes, Deep, AB are included in the second bracket. Look, this is a function f of x, you have expanded it in this way, and here you can see a term L. What is this L? So your f of x is defined between the interval b minus a. So let's say between a and b, a and b, so interval b minus a, this is 2L. Total interval is 2L. So half of that interval will be L, and that L is here. So let's say if you have minus pi to plus pi, if this interval is there, so L will be pi, because the total interval is 2 pi, so L is pi. Note it down quickly, then we will go for some useful integrals which will be used at different course of time. Hurry up, guys. Let me just give you some of the useful integrals. These integrals will be very necessary while you do the calculations. Look, I am writing a general limit a to b. A to b can be anything. It can be 0 to pi, it can be minus pi to pi, 0 to 2 pi, and so on. So a to b sin n pi x by L dx equals to a to b cos n pi x by L dx. This will be 0. Okay, for the time being we are considering that b minus a, this is 2L. Okay, remember this thing, b minus a is equals to 2L. So it can be minus L to plus L or 0 to 2L. Number 2, a to b sin m pi x by L dx. अच्छा, sin m pi x by L multiplied by sin n pi x by L dx. this will be, what are you saying, fourth point, this one, it has only a finite number of discontinuity in the interval. So there may be some discontinuity in the given interval. Okay, just hold on. If you have a function f of x like this, so let's say a function is going like this and the value is not defined here, it is discontinuous here. At this particular point the function has discontinuity, then again it is going up, again it has discontinuity. In this way, if it has, so it can have finite number of discontinuity in the interval. So in the interval maybe there may be one discontinuity or two discontinuity and so on. So that discontinuity is to be finite number of discontinuity. A to B sin m pi x by L and sin n pi x by L dx, this will be equals to A to B. It is valid for cos also, cos m pi x by L cos n pi x by L dx, this is equals to L times delta mn. Okay, what is its meaning? What is the meaning of this? If you, let's say, have 0 to 2 pi sin square, let's say x dx, what will you get? It is L delta mn. So when we are writing sin square, it means m and n are same. So L delta mn, L is 2L is equals to 2 pi, so L is equals to pi. For this kind of case, it will be pi. Similarly, it goes for cos. Number 3, A to B, if there is a cross of sin and cos, m pi x by L cos n pi x by L. So when you see a product of sin and cos, you can blindly write it 0. This term also appears quite frequently, sin n pi. For any value of n, this will give you 0. On the other hand, if you consider cos n pi, then the value will depend on the value of n. For odd value of n, like cos pi, cos 3 pi, cos 5 pi, that value will be -1. For even value of n, 0, 2, so cos 2 pi is +1, so that is decided by -1 to the power n. So these are the few things which you must remember while calculating the Fourier series expansions, Fourier coefficients. Now there may be multiple cases or different versions of Fourier series expansion. I will tell you one version first, and if you understand that one version, then all the other version will be very clear to you. So let's give the heading. Evaluation of Fourier coefficients. So in your examination, you will be asked to find out the Fourier coefficients. Let's say we have a function f of x, it is defined in the interval -L to +L. So total interval becomes 12. Okay, then you can expand Fourier f of x in Fourier series as this a naught by 2 plus n equals to 1 to infinity an cos n pi x by L plus n equals to 1 to infinity Bn sin n pi x by L, where this a naught term is given by, you see, 1 upon L minus L to L f of x dx n is equals to 1 upon L minus L to L f of x cos n pi x by L dx, and Bn is equals to 1 upon L minus L to L f of x sin n pi x by L dx. Now there are two things. Firstly, what will be this coefficient? 1 by L, 1 by L, 1 by L we have written. So just remember this one formula. Note, coefficient of integration. Coefficient of integrations will be 2 upon interval. You see, 2 by 12 is 1 by L, and this limit minus L to L, we have written minus L to L. This limit you will copy paste, whatever limit will be given for f of x in the question, you will just write it as it is, and other things you already know, f of x cos n pi x by L dx, f of x sin n pi x by L dx. Okay, so just remember this coefficient of integrations is 2 upon interval, and your things will be done. Now before going to solve problems, let me just give you another thing, how to know whether a function is even or odd. Do you know how to check whether a function is even or odd? Look, if I give you a function f of x, then you can easily check it whether it is even or odd by putting x equals to minus x. So you will calculate f of minus x. If you get f of x, that is even. If you get minus f of x, that is odd. This one you know, but when you have to decide it from the graph of a function, whether the graph is an even or odd, how will you decide? That is the main question here. So first of all, let's know the trivial thing, how to check whether a function is even or odd. If a function is even, the graph is symmetrical about the y-axis. For this Fourier series problem, you have to recognize the function from its graph, whether it is even or odd. So if a function is even, the graph is symmetrical about the y-axis, and if the function is odd, the graph is symmetrical about the origin. Yes, Ajay, Harani, Murli. Even function, the simple definition is f of minus x is equals to fx. This is one definition. Odd function means f of minus x equals to minus f of x. But from the graph point of view, you need to understand. For the even function, you see f of x equals to x square. This is symmetrical about the y-axis. For odd function, we have taken f of x equals to minus f of x equals to x cube. This is symmetrical about the origin. Now let me explain this to you with the help of graph. Look at this graph. Y equals to x square means this is an even function. As you can see, it is symmetrical about the y axis, means if you put a mirror at the y axis, and if you see, look at this, the image of this thing, it will form like at this position. So this is symmetrical about the y axis. It is like the mirror image about y axis. But for this one, y equals to x cube, this is an odd function. Is it a mirror image? If you put a mirror here, y equals to x cube, it should have come in this way if it is if it were the even graph, but it is coming in this way. So this is symmetrical about the origin, not about the y axis. These graphs have 180 degree symmetry about the origin. If you turn the graph upside down, it looks the same. Understood now? So simple check for even function. What you gonna do? You will just imagine a mirror as the y axis, and if you see that it is giving us reflection, then that will be even function. If it is not giving that kind of thing, then that will be odd function. I hope this one is understood. Let me just ask you a simple question. If you have a function like, if you have a graph like this, let's say I am giving a graph like this. You have a graph like this. Is it odd or even? Is this odd or even function? Can you tell me this graph? So name them. For odd, mirror in x axis. No, mirror in x axis, how will it come? It will not change side, na? Mirror in x axis, if you consider, then it should have come in this way, but that is not happening. So that is not right. Okay, only mirror about y axis. Got it? This is not mirror about x axis. This is odd function. So you will just check this one thing. Forget about the other. Just put a mirror along y axis. If you see its reflection on the other side, then it is okay, otherwise not. So this is an odd function. And let's say another function I would like to give, just to give me a moment. Let's say 3. I am just giving you multiple examples so that you understand this thing very clearly, because this is very important to understand. Now tell me, what about this graph? Is it odd or even? Number third, odd or even? बताइए. This one is fourth. This is obviously even. So I hope you have now understood how to decide whether the function is even or odd. Now as you can see, if fx is even function, what will be the value of a0? You will have some finite value, but what will happen if fx is an odd function? If fx is odd, a0 will be 0. Odd into even, look, multiplication of odd function and even function, what does it give you? It gives you an odd function. So if fx is odd, cos even function, so product of them will be odd function, so that value will be 0 if fx is odd. If fx is odd function multiplied by odd function, this will be an even function. So if fx is odd, sin x is odd, so both multiplication will be even, so this value will be non-zero. And even function multiplied by even function, that will be even function. I hope you know all of these things. So these are very necessary to understand, simple thing but very necessary. Odd into even, odd into odd, even into even. And remember two more things. When you have, let's say, minus L to L or any interval, let's say, okay, let's just take general interval a to b. Even function dx, this will not be 0, but if you have odd function dx, you can blindly write it 0. Okay, if the intervals are given like this, symmetrical, minus L to L. And there is a very logical reason for this. Okay, now what is integration? Integration is nothing but area under the curve, right? I hope you know this. Integration means area under the curve. Now when you talk about let's say an even function, in a period, the integration is not 0, but when you consider odd function, so odd function, let's say like this, okay, so it is like adding this plus area minus area, so that is why it is giving you 0. So these are the fundamental things you should know. Let us go for a problem. Okay, do this problem. You are given the function f of x minus k between minus pi to 0 plus k between 0 to pi, and fx is a periodic function with period 2 pi. The Fourier series which represents the above function has sine terms only, cosine terms only, sine terms and constant, cosine terms and constant. Can you do this? Actually, without calculating, you can do this problem. You can tell me the answer. Tell me the answer quickly. See how, see constant will be there. Constant means it is talking about the A0 term. Okay, between minus pi to 0 it is minus k, so it is like this, minus k, and between 0 to pi it is plus k. So what is the nature of this graph? This is an odd function. A, very good. Odd function means that integration minus pi to pi f of x dx will be 0, a0 will be 0, and cos is an even function, so even and odd is odd, so for odd function integration will be, that will be 0. But for sine is itself an odd function, so odd into odd will be even, so only sine terms remains. So let's write the solution here. The given function is an odd function, hence a0 and n will be 0. No issue in this. For Bn, you see what is the interval here? Minus pi to pi. Interval, you first calculate interval minus pi to pi, so it is 2 pi. 2 by interval 2 by 2 pi. Limit, you need to copy paste the limit. Firstly, between minus pi to 0, minus pi to 0, value is minus k, sine. Now you see what we learned. As I told you, if you learn the first one, the remaining will be learned very easily. Here it is minus pi to pi, the interval is 2 pi, so 2l is equals to 2 pi, so l is equals to pi here. So if you have cos or sine n pi x by l, so this is equals to n pi x by l is pi, so now here we can write nx, right? So we will write sine nx dx plus limit, copy paste 0 to pi plus k sine n pi x by l becomes nx dx. Is it understood till now? Tell me. The general interval a to b 12. So you will always compare with this. It may be minus pi to pi, it may be 0 to 2 pi, and so on. Is this line clear to everyone? Harani, Ajay, Deep. So let us calculate this. The first term minus k by pi sin nx, the integration is minus cos nx divided by n, the limits is minus pi to 0. What about the second one? K by pi minus cos nx by n. Clear? So this is k by pi, this minus plus. Now you see, if you put cos 0, x equals to 0, so cos 0 is 1 minus, if you put minus pi, so cos n pi is minus 1 to the power n. I have given you the formula before, divided by n. Look, we are doing in a very step by step manner. K by pi minus taken common, cos n pi now. Okay, so what will be this value? Cos n pi means minus 1 to the power n minus cos 0 is 1 divided by n. Look, if you take a negative sign common, it becomes the same. So this 2 times k by n pi 1 minus 1 to the power n. So what you can write? F of x is equals to a0 by 2, a0 is already 0, an cos n pi x by l, that is also 0. So what we are left with? Bn sin n pi x by l. So here sin nx, okay na, 2k by pi sum over n equals to 1 to infinity bn. So 1 minus 1 to the power n, 2k by pi we have already taken, so divided by n, sin n pi x by l becomes sin nx. So this is 2k by pi. If you put the values of n, so n equals to 1, you put, what you get? This is 2 by n. So 2 by 1 sin x. If you put n equals to 2 by means even values, you see this will be, term will be 0. So only what values will remain? So 2 by 1 sin x plus 2 by 3 sin 3x plus 2 by 5 sin 5x and so on. So if we take the 2 common, 4k by pi 1 by 1 sin x plus sin 3x by 3 plus sin 5x by 5 and so on. So it is containing only sin terms. So option A is the correct option. Done? Any question, guys? How become nx? I told you na. Whether you have cos n pi x by L or sin n pi x by L. So these were the intervals when you have the interval a to b, means the total interval was 2L. For that case it was n pi x by L. Now n pi x by L, this will be, for the present case, what is the interval? You see it is from minus pi to pi. Okay, for the present interval it is minus pi to pi, total interval is 2 pi. So 2 pi should be equals to 2L. So L is equals to pi na. So n pi x by pi, pi get cancelled. So what you are getting, nx na. So n pi x by L is nx here. I hope you have understood, Murli. Let's go on to the next problem. If the Fourier series of the function f of x equals to x mod x, x is lying between minus 1 to 1. So you can read it like this 2L interval, you can read it like minus L to L. Okay, now this may be minus L to L, or it may be 0 to 2L. So here it is minus 1 to 1. So if you compare it minus L to L, so L equals to 1, 2L is equals to 2. So if the Fourier series of the function x mod x is written in this way, then which of the following is correct? What kind of function it is? Even or odd? First tell me that. What is the nature of this function f of x equals to x mod x? Is it even or is it odd? Look, f of x is equals to x mod x. You need to take the interval from minus 1 to plus 1. So this is minus 1, 0, plus 1. You have to consider f(x) versus x. It is odd function, good. So when you talk about minus 1 to 0 means x less than 0. So for x less than 0 it will be minus x square, and when it is x is greater than 0, it is x square, isn't it? So x is y equals to x square graph between 0 to 1, it will look like this, minus x square, it will be going like this, this part corresponding to x square, this part corresponding to minus x square. And as you can see, if you place a mirror along the y axis, you are not seeing any reflection. So it will be an odd function, symmetric about the origin. So for odd function, what will be there? As this is an odd function, a0 will be 0 and an is also 0. You can directly write. So what we will have? Bn. But in the option, as you can see, the an and a0 both terms are 0. So you must calculate the b terms. So let's calculate bn to get the correct answer. Bn 2 upon interval. What is the interval? Interval is 2 minus 1 to 1. So 2 upon 2 minus 1 to 1. For the time being, let's write f of x dx, because f of x has different value. Okay, f of x, अच्छा इसमें sin nx भी है ना, sin. Now let's decide what will you write here. Previously we wrote nx, but here let's just check n pi x by L. This is our original formula. So here n is n, pi is pi, x is x. What is value of L? What is the value of L? As you can see, it is L is 1. So n pi x by 1. So you will write here n pi x. Okay. Sin n pi x dx. This is equals to fx. This is an odd function. Sin n pi x. This is an odd function. So multiplication of these two will give you an even function. So if it is an even function, we can write 2 times 0 to 1. Can you write it? For even function, we can write it 2 times 0 to 1. So for 0 to 1, the value of fx is x square sin n pi x dx. I hope this is understood, guys. Now to solve this integration, we can make use of the integration by parts. So Liet formula, you know. So this will be taken as u, this will be taken as v. Then what you gonna get? 2 times u integration dv. So minus 1 by n pi cos n pi x limit 0 to 1, minus plus x square derivative. So 2 by n pi 0 to 1 x sin n pi x, from that you are getting cos n pi x dx. Is it clear or not? Tell me. We are just doing integration by parts. You can do it by yourself. This is equals to 2 times, if you put cos x equals to 1, so cos n pi is minus 1 to the power n, and this minus n pi we are keeping at the denominator. Okay, and if you put x equals to 0, then that will not count because x square is there, plus 2 by n pi. Again you can use integration by parts for this. X equals to u, cos n pi x is equals to b. So what you will get? X times sin n pi x by n pi plus, look, derivative of x is 1 and integration of cos is sin, then integration again minus cos, so minus plus cos n pi x. Look, once derivative of cos will give you n pi, then it will become sin, derivative of sin will give you another n pi, so this will become n pi square 0 to 1. this is equals to how much? You see, this will remain minus 2 minus 1 to the power n, and minus we have taken, so n pi. 2 into 2, 4. Now this x, for x equals to 1, sine term will make this term 0. For x equals to 0, this x term will make it 0. So the first term is not considered. Second term, if you put x equals to 1, you get cos n pi, so minus 1 to the power n, and this n pi square, so n pi square into n pi cube, cos n pi minus 1 to the power n minus cos 0 is 1. So this is the expression of Bn. Now let's check what we have to find out. B2, B4, B3. So A0 is 0. This one is there. Okay. B2, let's check B2. B2 is how much? B2 means n equals to 2. So minus 2 minus 1 to the power 2 by 2 pi plus 4 by 2 pi cube minus 1 to the power 2 minus 1. So second term is 0. So we are only having this first term, minus 2 by 2 pi minus 1 upon pi. That is what is given, minus 1 by pi. So option B. You can check the other options also. By putting n equals to 3, you can see that it will be 0. It will not be 0 actually. If it were 0, then that would be the correct option. It will not be 0, as you can see it clearly from this expression. Let me know if anyone has any doubt. Is it done? One case we have discussed. Now the other cases are just the special case of the first case we have discussed. So you can take this case as case 1. This is the first case. Case 1, where your fx is defined between minus L to L and the interval is 2L. Let's talk about case 2. For case 2, we are taking the function f of x. This is now defined in the interval. Instead of minus L to L, it is now defined 0 to 2L. So in that case, this formula is same, a0 by 2 plus n equals to 1 to infinity n. So cos n pi x by L Bn sin n pi x by L. So what is the interval here? 2L. So what will be the value of a0? 2 by interval 2 by 2L, 1 by L. Limit, as I told you, here the limit will be 0 to 2L. Whatever limit will be given, we will just copy paste, and other things will remain as it is. Okay. an will become 1 by L 0 to 12 f of x cos n pi x by L dx. Bn will be 1 upon L 0 to 12 f of x sin n pi x by L dx. Here also you should remember this thing, that coefficient of integrations 2 upon interval. Now you will tell me case 3. For case 3, we are taking a function, instead of f of x we are taking, let's say, f of t. F of t is defined in the interval, let's say, 0 to 2 pi by omega. Okay. Then how will you express f of t? Look, a naught by 2 will remain a naught by 2 plus n is equals to 1 to infinity n cos. What will be this argument? N pi x by L. What you gonna write here for 0 to 2 pi by omega? Tell me quickly, then I will understand that you have understood. What should I write here? Quick, Harani, Deep, Murli, Ajay, tell me what should I write within this bracket? N omega x, but it is a function of t. Should you write x yet? X is what? Where from x is coming? X is a variable. When the function is f of x, but I have given you f of t. Still x will come. So here is, as you can see, 2L is equals to 2 pi by omega. L is equals to pi by omega. So n pi x by L will be n pi, x is t here, L is pi by omega. So what do you have? N omega t. Yes, Deep, Ajay. So n cos n omega t plus n is equals to 1 to infinity bn sin n omega t. That is why I told you, if you understand the first case, the remaining cases you can easily understand. So tell me now, what will be the value of a0 then? 2 by interval. What should I write here? Can you tell me? What will be this integration coefficient? Ajay, Deep, Murali, Harani. What should be this integration coefficient? Same formula, 2 by interval. What are you getting? Omega by pi. Very good. Limits, you don't need to think about the limits, you will just copy paste. F of t dt. What will be an? Coefficient are same, 0 to 2 pi omega. F of t cos n omega t dt. Bn f of t sin n omega t dt. Clear? Yes. Let's take one last case, case 4. Now you will tell me everything. A function f of t is there, it is defined in the interval minus pi by omega to plus pi by omega. So now f of t will write as a naught by 2 plus n equals to 1 to infinity an cos. What will you write here? Tell me quickly. Bn sin, what are you going to write here inside the parenthesis? What you gonna write, guys? Quickly tell me. It is either minus L to L or 0 to 12 when the period is 12. N omega t. Very good. Simple as that. So L is equals to pi by omega here, isn't it? N pi x by L as usual, n pi t by pi by omega, n omega t. Now what will be a0? 2 by interval omega by pi minus pi by omega to plus pi by omega. Here you have to copy paste the limit. I hope you have now understood the things very well. Now you can handle any case, any kind of interval, any kind of thing you are given, you will be able to handle, isn't it? Now are you feeling confident? Like any kind of interval, any kind of function you are given, you will be able to handle. Yes or no? Let me give you a trick question. The next problem I am giving you, That is a Fourier series problem, but you can do that without using Fourier series, actual Fourier series. This is a trick question, okay? If the function f of x equals to sine qx, x is defined between minus pi to pi, is expanded in Fourier series, then which of the following is incorrect? Even if you do not know, okay, you need to know Fourier series, but if you don't use the rigorous calculation, then also you can find out. Can you tell me the answer quickly? Okay, as you can see, for this particular problem, what are the specifications we have? Minus pi to pi. So here L equals to pi, interval 2 pi. So your n pi x by L, let's evaluate that. N pi x is x, L is pi, so nx. So effectively your Fourier series expansion becomes a naught by 2 n equals to 1 to infinity an cos nx bn sin nx. But what is the nature of this function sine cube x? Is this an odd function or even function? Odd function. Therefore a0 an both of them will be 0. Now one way is there, you can calculate bn in a straightforward way. You can calculate bn, and after that you can put n equals to 1 or n equals to 3 and you can find out. Now why I am saying this is a trick question, you see, we know this formula, we have done it in your class 12, class 12 no, class 10 I think. Sine 3 theta, sine 3x is equals to 3 sine x minus 4 sine cube x. You know it or not? So from this, what is the value of sine cube x? Sine cube x is equals to 3 by 4 sine x minus 1 by 4 sine 3x. Can you write it? Now notice one thing, when you will be writing f of x is equals to n is equals to 1 to infinity bn sin nx, what you gonna get? Put n equals to 1, you get b1 sin x, n is equals to 2, b2 sin 2x, b3 sin 3x, and so on. So if you just compare, this is your f of x, 3 by 4 sin x, so b1 is obviously 3 by 4, b2 there is no sin 2x term, so b2 will be 0, b3 sine 3x. So b3 is equals to minus 1 by 4. You can do it manually the way I have already told you. Bn, you can use the formula 2 by interval, limit, copy paste, f of x sin n pi x by l, whatever it is, you can evaluate it. You can find a general expression, you can evaluate it. So we are doing it using a shortcut because we already know the formula of sine cube x. So if you know, why should I not use? So deep, you are getting option C, b1 is equals to 3 by 4. Yes, option incorrect, you have to find out. This is correct, na? b1 is equals to 3 by 4. You have to find out. Read the question very carefully. Which one is incorrect? So b1 is 3 by 4. It is correct. a0 is 0. It is correct. a1 is 0. It is correct. b3 is 1 by 4. This is incorrect, and that is the correct option. Look, this kind of situation happens in an examination. Sometimes we desperately try to solve a problem, and when we see, okay, I have got an answer and it is there in some of the options, but you did not read whether it is talking about which is the correct or incorrect. All the remaining 3 is correct, only 1 is incorrect. Yes, so you have to be very careful in reading the question. Otherwise you will regret very much, because first of all you have done the solution rigorously with too much of hard work, and you get so much overjoyed that you choose the incorrect option. Even after doing the correct solution, if you are choosing the incorrect option, then that is very unfortunate. चलो आगे बढ़ते हैं. Let's move on to the next problem. Can you do this problem? Now I think you can solve any problem. The fundamental thing is clear, then everything will be sorted out. If x is equals to sum over k equals to 1 to infinity a k sin kx for minus pi to pi, the value of a2. Look, don't get confused. Here we are habituated in using bk, right? For sine we have b coefficients, but intentionally they have given you a. So treat that accordingly, don't get confused. Sometimes examiner may use different symbols to confuse you. Can you do it, guys? Can you do? This is quite obvious. The x is an odd function, so obviously your a0 and an, they are 0, right? So that is why it is directly giving you the sine part only. Are you able to find out the answer? Here what is L? L is equals to pi, interval 2 pi. Okay, so we are directly calculating a2, not an. 2 by interval, limit, copy paste, f of x. Look, we will put the formula of sine. Now n pi x by l, n pi x by pi, so nx. So when you choose n equals to 2, what you want to put here nx, instead of nx we write 2x, because we are particularly interested in a2. Clear? 1 by pi. X is an odd function, sine is also odd, both product is even, so we can write 2 times 0 to pi x sine 2x dx. Two by pi x sine 2x, integration by parts, x is u, sine 2x is v. In Fourier series problem you will see lot of integration by parts thing. Sine 2x integration is cos 2x by minus cos 2x by 2, limit 0 to pi. Integration, the derivative of x is 1, integration of sine 2x cos 2x by 2 dx. Have we done any mistake? D, yes, option D is coming. अच्छा, यहाँ पे क्या होगा देखो, माइनस डेरिवेटिव ऑफ एक्स इज 1, इंटीग्रेशन ऑफ साइन माइनस कॉस, माइनस माइनस प्लस हो गया ना, but it doesn't matter, at the end it is 0. But accuracy is most important. Tell me guys if you have understood this problem or not. The next problem I am going to give, this problem is from TIFR exam. This problem came in TIFR 2010. A function f of x is defined in the range minus 1 to 1 by this. So obviously you can say L equals to 1. The first few terms in the Fourier series approximating this function. देखो, don't get frightened by looking at the size of the problem. What will be your first task? Your first task will be, for this kind of interval functions, your first task will be to draw the function. Okay, let's draw it. This is 0, this part is greater than 0, this part is less than 0, and minus 1 to plus 1. X greater than 0, 1 minus x. So 1 minus x, at x equals to 0 it is plus 1, at x equals to 1 it is 0. So as you can see, this will be a curve like this, and for this one, at x equals to 0 it is 1, and x equals to minus 1 it is 0. So what is this function, even or odd? Even function. B you are getting, is it B or A? If it is even function, then sine term will not appear, na? Fx sin n pi x, so even into odd is odd. So sine terms will not be there. So we can remove option B. F of x is an even function, hence Bn will be 0. Graph, what is this graph? Y equals to mx plus c. This is a graph, is a straight line. Here slope is negative, m equals to -1, so negative graph. Here slope is positive, positive graph. And you can also cross verify by putting the value. See, if x equals to 0, if x is 1, you are talking about this one, this is 1. At x equals to +1, if x is 0. So a straight line with negative slope with its value at x equals to 0 is 1, x equals to 1 is 0. So this that is why we are getting a straight line like this. For this one, you see, if you put x equals to -1, 1 minus 1 is 0. If you put x equals to 0, you get 1. Understood the graph? Bn is equals to 0. So what will be your f of x? A0 by 2 plus n is equals to 1 to infinity an cos n pi x by L. Calculate n pi x by L. N pi x L is equals to 1. So n pi x. Right. Let's calculate first A0. What is A0? 2 by interval. What is the interval? Interval is 2. 2 by interval is 2 by 2. 1. Limit, copy paste, -1 to 1 f of x dx. -1 to +1. -1 to 0, let's say. Negative interval, the value is 1 plus x. In the positive interval, value of fx is 1 minus x. So what are you getting? Acha, we could write 0 to, as you know what is already an even function, we could write 2 into 0 to 1. Okay na? This is nothing but 2 into 0 to 1. Between 0 to 1 the value is 1 minus x. Two into, as you can see, it is x minus x square by 2, 0 to 1. 2 into 1 minus 1 by 2, 2 into half is 1. A0 is evaluated, let's say an -1 to 1 fx cos n pi x dx. We are writing directly 2 because this is an even function, this is an even function, so product is even. 2 times 0 to 1, f of x in the positive interval is 1 minus x cos n pi x dx. Let's do integration by parts. 1 minus x is u, cos n pi x is v. Okay, so 1 minus x sin n pi x by n pi minus derivative of 1 minus x is -1. The integration of cos is sin again integration minus cos, so it will become minus minus minus, so 3 minus 3 minus, so minus cos n pi x divided by n pi coming twice n pi square, limit 0 to 1. This is equals to how much you will get. Look, the first term will be vanished for x equals to 0 or 1. It's all about the second term. Okay, so if I put the value of x equals to 0 first, then that will absorb this minus sign. So 2 by n square pi square 1 minus cos n pi. Okay, and as you can see, okay, we have places, we have good amount of places. Why should I write it here? If you choose, let's say, odd values of n, for odd values of n, okay, let's do another line. 2 by n square pi square 1 minus cos n pi is minus 1 to the power n. This one we know. So if you choose n equals to odd, so this will be minus 1 minus minus plus, so 4 by n square pi square for odd n. Now for even n, minus 1 to the power n is plus 1, so that will be 0. And hence we can write f of x is equals to a0 is 1, so a0 by 2 1 by 2 plus we have, let's say, 4 by pi square, constant taken common. You see only what values are there, so 1 3 5 7 and so on. F of x one by n square cos n pi x. So if you put the values, half plus 4 by pi square n equals to 1 cos pi x, n equals to 3 4 by 9 pi square cos 3 pi x plus 4 by 25 pi square cos 5 pi x, and so on. Which option is it matching with? Is it matching with option C or A? I think A. A. Half term is there, na? Tell me guys if you have understood this or not. One problem I will be giving you as homework as usual. For the Fourier series problem, you need to practice, okay? Otherwise you will forget. Look, when we are doing this today, you find it very easy, but if you don't practice enough, you will eventually forget. So practice is important. And okay, one thing I remind, tomorrow Sunday There will be a Sunday test as usual. And what should be the syllabus? Tell me. I have not prepared the question yet, but I will prepare today. What should be the syllabus? We have covered dimension analysis. We have covered vector analysis. We have covered matrix. And we have covered Dirac delta, coordinates, special function. What should be the syllabus? Tell me. First three will be okay for you: dimension analysis, vector and matrices. Maybe 15 question or 10 question, so that you can complete the exam in 1 hour maybe. First three we are keeping, right? Dimension analysis, vector and matrix. Everyone is okay with this? Okay, I will add you those who are enrolled in this course, batch course. I will add you to the test series because the test series was complimentary. So I will add you to that test series, and in that test series you can give the Sunday test. Okay. I will share the more details after making the questions and all. I will share the details on the WhatsApp group and maybe on the Telegram channel also. Telegram channel, all of you join. This is the Telegram channel link, Physics Hub 111. Link is given in the description. Okay, so we will conclude this session today, but I will give you a homework problem before I end the session. Take this problem as homework. The problem reads like this: if the periodic function f of x equals to cos hyperbolic x plus sin hyperbolic x minus 1 to 1 is expanded in Fourier series, and it is found that a3 is equals to k times e square minus 1 by e into 1 plus 9 pi square, then what is the value of k? Good question, you will try at home. With this note, let's end the session here, guys. Thank you very much. If you are new to this channel, please subscribe the channel and don't forget to press the bell icon. And everyone, like the video. Okay, bye bye, take care. See you on Monday. Monday 7:30. Okay, from Monday onwards we will be taking it at 7:30 because then we can take longer sessions. Chalo, bye.